In this video we'll be looking at the energy stored by a capacitor. Now we know that energy is directly related to potential difference and charge, based on the definition for potential difference from the electricity topic, where we stated that potential difference is the energy transferred per unit charge. Now in this case, with a capacitor, we're building up charge on both plates. As that charge builds up, we end up with an increasing opposition to the flow of current. The more negative one plate becomes, the less electrons it will allow to add to that plate as it repels their approach. So that means more work needs to be done to put electrons onto the plate. As such, this isn't as simple a relationship, and as such we say that it has a V/2 relationship, which is to say that the energy is a half QV rather than being QV directly. So E represents the energy that we're storing in this capacitor, whereas then Q is obviously the charge on the plate. And V represents our potential difference between the two plates, the positive and the negative. Now this equation is very easy to substitute into, as if you don't have a value for Q or a value for V, you can use the capacitor equation from the previous session. And substituting in is quite straightforward, but also given on the datasheet. Now you'll also be expected to understand this relationship graphically, and again it is something fairly obvious to us. So if we form a fairly straightforward graph, just like we did last time, showing charge against potential difference, we know that we should end up with a directly proportional relationship. Now whilst that gradient is our capacitance, the area under the graph will be represented by Q times V halved, which we know from the equation is the energy stored. So this total area represents the energy stored in a capacitor. So this is the sort of thing you might be asked to find graphically, or just to interpret from a set of graphs, much like the gradient's meaning in a multiple choice question, for example. Thank you for your time.